Hello and welcome to one more tutorial on using pin change interrupts on the Arduino Uno. So here are the snippets to our code, and if we want to use pin change interrupts, it's advisable to include this line avr interrupt.h. So we are using pin 12, so that's been initialized as LED pin. The pin 8 will be used for interrupt, and that's been initialized as pin_8. So now there is this value called light. So this is the value which will be toggling in the interrupt vector, which will enable us to turn on and turn off the LED. So this is a Boolean value, and since it's being manipulated inside an interrupt vector, it's been initialized as a volatile bool. And second interesting thing is this variable called allow. So this is basically a flag which allows the microcontroller to take cognizance of the interrupt or not to take cognizance of the interrupt. As I explained in the previous video, when we press the switch, there are two transitions in case of a push button switch, high to low and then low to high. And the pin change interrupt doesn't distinguish between these two states. And having this variable as a flag enables us to distinguish between these two states. So what we'll be doing is that we'll be distinguishing and taking cognizance only of high to low and ignoring the low to high transition. Then there is an integer called count. This is merely for diagnostics, and I've just added it so that we can keep a track of the number of times that we are pressing the button. Then the LED pin, that is pin 12, is initialized as output. The pin 8 is initialized as integer pull-up. So now this is a very interesting use of the pin 8. So what the integer pull-up does is that I demonstrated the use of a pull-up resistor. So by initializing as integer pull-up, we use the internal pull-up resistors to hold this pin at high or 5 volts irrespective of what's happening outside. So it's like having a pull-up resistor without actually physically connecting a pull-up resistor to the circuit. Then we have the PC-ICR register, in which we have enabled the bit which tells the microcontroller to watch pin 8, and then we have enabled the PC mask register, pin change interrupt mask register, to watch the change on pin 8. We have cleared all interrupts with CLI, and we have enabled all interrupts with SEI. So that's a good practice. And now we move on to the interrupt vector itself. I explained the bit read in a previous video. So what we are doing here is that we are taking in all the values of port B and watching the first value on it, that is pin 8 value. And if pin 8 happens to be 0, that is pin 8 happens to be low, and the interrupt flag is true, that is the pin change has happened from high to low, then we act on this interrupt, otherwise we do nothing. So when this happens, the light goes to not of light, that is light gets toggled, and since the interrupt has been triggered, the allow value is changed from true to false. So this means that when the pin goes from high to low, then I will act on it, but when it goes from low to high, I do not act on it. And this is our void loop. So here what we are doing is that in case allow is false, that is the interrupt has been triggered and the allow flag has been made false, then we increment the value of count. We print the value of count to the serial monitor. This is again merely for diagnostics. You can skip this in a real experiment. We write the value of light to LED pin. So if light happens to be set to true, then this will cause the light to come on, and if it happens to be false, then the light turns off. And if we see here, we are toggling light. So every time that we press the push button, the state of light is going to change. So we used a push button and a pin change interrupt to set up a toggle switch. Now this delay, this is an innocuous kind of a line, but it's actually quite important. And it's important because of the reason that when we use a mechanical switch, the transitions are not exactly clean. So we go from high to low and then low to high. So this is what we expect. But what actually happens is that you go from high to low, and then there's a lot of chatter before it comes down to low. And similarly, when you go to high, you have a lot of chatter like this, and then you settle down here. So this region is the region in which the switch is actually bouncing. And this delay is basically a method called debounce. So what it does is that by delaying, we tell the microcontroller not to act during this period, not to take cognizance of during this period, and that kind of shields us from these multiple transitions. If you skip this code, then you would find that if you're not very careful in pressing the push button, then you would have a few unwanted transitions happening on the LED. There are other more complicated ways to implement a switch debounce, which we'll be covering in later tutorials. So now we are ready to flash the code. I connect the Arduino. So I click on this to flash the code. So the code's been successfully flashed. And as you can see that here's the push button. The push button goes to pin 8. And here's our LED. It's connected in series with the resistor. The resistor is grounded here. And this wire is snaking all the way to pin 12. So I turn it on. So press the button, and as soon as I press it, the LED turns on, and when I turn it off, it turns off.